So we can keep this pretty informal, so if you guys have questions when going through stuff, just feel free to ask. Just make it more of a conversation. So I'm Ian Bernstein. I'm a roboticist and a maker. Been building robots for a while. Today, I'm going to talk a little bit about robots, where robots are at today, where we're going with robots, kind of how to make robots, and yeah. So I started building robots when I was 12. I had started homeschooling when I was in 4th grade, and heard about this, didn't really know much about robots, but heard about this robotics conference that was going to be happening a couple hours from where I grew up in New Mexico. And went the first day and didn't really know what it was, showed up and they had a workshop as part of the competition. And it ended up building my very first robot. And it was sort of like made out of a broken cassette player, and it was cut in half, and then we added some components, a solar cell and some other things, and it would basically charge up a capacitor, which is like a battery, and then the robot would move a little bit. And I was just so into it that I ended up going the other 3 days of the competition, built another couple robots, and that's pretty much like all I did through middle and high school, was just take stuff apart. Like my parents' friends would bring us all their like broken electronics and VCRs and cassette players, and I didn't really have any money, so I'd take a lot of the components out of this broken stuff and use that to make probably 60 or 70 robots that I made before I went to college. Went to school for electrical engineering, went to a couple different schools, and then dropped out. I wanted to learn about business, so I started a web design company. And then in 2009, I met this guy, Adam Wilson, and we came up with the idea of controlling physical things with a smartphone. And back then, like now, it seems like everything connects to your phone. Back then, there wasn't really anything. We were like probably one of the first couple people in the whole world connecting physical things with the smartphone devices. And we prototyped a bunch of stuff because we could do anything at that point. There wasn't any companies doing things. So this is an example of something that we created.
Gearbox test demo. My name is Adam Wilson.
I'm Ian Bernstein, and I'm going to show you a commercial demo of Gearbox. So in this application, we're going to start Gearbox.
You can't see it. Oh.
We're going to open our garage door project. Now that the project's open, hit the button. The garage door.
So we made a bunch of other stuff, like I bought a remote starter off of eBay and put it in my car, and you could start the car and roll down the windows from your phone, control like lights and door locks and stuff like that. And with these kind of crappy videos that we put together, we got into a program in Boulder called Techstars. And Techstars is a program that you can apply to, and they give you some money, and they hook you up with lots of mentors and sort of teach you how to build a company in a few months. And probably the hardest part was trying to figure out what we were going to make. And we ended up sort of taking the two of our favorite things. One was robots, and one was playing video games. And we came up with this idea for a robot ball that connected to your smartphone. So we had the physical ball in the real world, and then on the phone we were taking advantage of the cell connectivity and the screen, touch screen, and all the other stuff. And we ended up coming out with this product, which is Sphero. And it's in a lot of schools right now. We distribute, we sell it in Apple Store and Brookstone and Best Buy and all over the world. But of course, this one's the final one that we actually produce and manufacture. It's injection molded. But it started with, of course, this is MakerFaire. This is our very first Sphero that we ever made. It's a lot of just sort of, I don't know, parts we had on our desk. So the shell for this one, it's a 4-inch size shell. We got it at Hobby Lobby, and they use it for making like Christmas ornaments. So it's sort of a blank Christmas ornament, and then we cut off the little tab where you'd hang it from your tree. And then the whole frame for the robot was just straightened out paper clips, stuff like that. And then a Bluetooth module that we just got off the internet from SparkFun. And then a few years later, we had the opportunity to go through Techstars again, and we moved out to LA to participate in their Disney Accelerator program. So this was, we basically just filled up Adam's van with all our stuff. We had our 3D printers, we had all our molding supplies, which is cool because you can 3D print like a tread in a hard plastic, and then you can mold it. So you can cast it, and then you can mold it in rubbers or different colors or whatever you want. And the first couple days of the program, we got to meet the CEO of Disney, Bob Iger, and sort of right at the beginning of the meeting, he's like, you gotta check this out. And he pulls out his phone and shows us a picture of BB-8 and said this was gonna be the new droid from Star Wars Episode 7. And he asked us if we could make it. So that night, when all the other companies had left, it was kind of secret in there, because this is a year and a half before the movie came out, and like nobody knew about BB-8. We'd seen it on his phone for like 10 seconds, so this is what I drew on my iPad right after. We were trying to remember like what it looked like, and like what colors it was, and how many eyes and antennas. And then of course, like when everybody had left the accelerator, we tried to make one. So this is a video that night after he showed us a picture of our hacked together, I think the first fully functional BB-8 out there. So it was super crude, and like this is the first iteration, like the head would spin around, and then we're like, oh, well maybe we need 2 magnets, not 1 magnet. So of course, then it took about 10 months to get from that, and then like thousands of iterations on it to get to the actual BB-8 that we started selling in 2015. So that product did pretty well. Kind of on the making thing, like actually like one of the hardest parts of making BB-8 is the decoration. Like how do you put decoration around a sphere? And it's basically like a rubber stamp. It's like pad printing, tampo printing. So you basically take a rubber stamp and you put it on the side of the shell and it leaves the mark, but of course you can only do one color at a time, and a rubber stamp can't wrap around a sphere. So you actually, like in manufacturing, there's about 100 different rubber stamps that have to hit it and align perfectly, and then rotate the shell and line it so all the graphics line up. And that took a long time to figure out. But then I started thinking, with all these products we were coming out with, that promise that I had when I was a kid, which was the robots that I'd seen in movies like Star Wars, R2-D2 and C-3PO, Rosie from the Jetsons, robots that aren't just for fun, but robots that become part of your family and can do useful stuff for us, like cooking and cleaning and doing the laundry. Newer ones like Baymax from Big Hero 6. I wanted to build a real one of these, and why don't we already have robots like that? So we looked at the robotics industry today and realized that it's just a lot of people building robots over and over. So on one side you have almost every university in the world has a team of electrical engineers and computer scientists and mechanical engineers and other disciplines coming together to build a robot. And they'll work on it for a couple of years, but then go back to starting to build another robot from scratch, usually when those people graduate and move on. And on the other side, there's a lot of people building really cool robots, like ones that you see here as well, with Raspberry Pis and Arduinos and lots of sensors that you buy from the internet to build a robot that can like avoid obstacles and stuff. But really people are just building the same sort of robots over and over and not really progressing it. And what we realized is this is a lot like how the computer industry was back in the 70s. and that people were just building computers over and over. So on one side you had big mainframe computers at universities and research labs. There was computer kits, and then you had people like Steve Wozniak and those guys in the Homebrew Computer Club that were trying to figure out how to build a computer with 25 chips, and then they'd go to the next Homebrew meeting and somebody would figure out how to do it in 22 chips. But they were just building computers over and over and weren't really doing a lot with the computers themselves until Apple came along and that sort of classic computer like the Apple II, that now instead of building computers over and over, you could just buy a computer that worked. So you plug it into the wall and 2 wires to your TV, and now instead of building a computer, people could write software for the computer and really start to figure out how computers could be used in the home and the office. And it took a few years to get to VisiCalc, which is sort of widely regarded as the first killer application for computers. And it was now at that point that somebody who didn't know what a computer was could go to the store and they're like, I've heard about these computer things. Like, why would I want one? What does it do? Oh, here's like the 50 applications that you can buy for it. You could buy different games and applications to do your taxes and stuff like that. And that's when computers really took off. So what we're working on is sort of the same thing. So instead of building robots over and over, we want to build a robot that just works, and we solve all the hard problems in robotics, like navigation, so that people can start to write applications for robots, figure out how they can be used in the home and the office. So this is a robot. You can see several of them just out to the left, kind of in the atrium out there. We have stuff like a structured light sensor, which is like an Xbox Kinect that lets you build a map of the world, a floor plan. So instead of having to know how to do SLAM and all the crazy math to take point cloud data and convert it into a 2D map of your home, you can just say, robot, generate a map, and then say, robot, go to the kitchen, go to the living room, and say something, and have voice recognition so you can communicate with the robot that way. Sort of, how do we make these things? A lot of our early prototypes, we just use off-the-shelf stuff. So these are all laser cut at a local makerspace in Colorado. There's dev boards, like the camera that we're using on this one is just a Microsoft Live Cam that we got on Amazon. There's dev kits that you can buy from Arrow, like the Dragon board, and on the other side is another cell phone class processor that you can just buy on the internet. And there's just a lot of software that pulls it all together. That's more like the hard part. It's like once you wire everything together, I have to write a lot of software to get it to work. And what can you do with it? This is an example of kind of a fun thing that our videographer came up with. So that's just one example. The robot's just really the tool. So it's all the things that developers and programmers are going to program these robots, and some of the things are fun, like getting a pizza. It's a little bit contrived, but some things could be more practical, like elder care. Like you could program the robot to respond to a loud noise and check out what's going on. So somebody, maybe your elderly parents, your grandparents, you could detect that loud noise, the robot could say, are you okay, yes or no? If they say no, then the robot could contact you. Same with like computer vision. We make it fairly easy to train the robot to recognize different objects or different things, like somebody laying on the ground wouldn't be that hard. So the robot could do a patrol, and if it sees somebody laying on the ground, it asks, are you okay? If they don't respond or they say no, again, it can contact you. So more practical stuff. Like I want the robot to be at our office, and when somebody comes in, it could say, who are you? Who are you here to see? If they say Ian, then it could like send me a message and then take them to a conference room. But that's the type of things you're now going to be able to do with the robot, where in the past, just getting the robot to not get stuck and avoid obstacles is the hard part. And then when I say program, it doesn't necessarily be coding as well. Like we made it easy enough that like you guys can just program it in a block-based language. So you can just drag blocks around. You can basically drag a block in that says go to, and then from a little drop down you say go to kitchen. And that's how easy it is to program these robots. It will be soon. So you don't have to know any code. So I'm excited about the future where we're taking robots not from just fun toys or vacuum cleaners, but robots that are doing useful things for us in the home and the office. Robots soon will come out where they can do many things and cook and clean. So that really, like, in the future, when you think about your week and how much like mundane tasks you do, like doing your laundry and folding your laundry, these can be done by robots. So that we can spend that time with our friends or like doing things that we really want to be doing rather than those mundane tasks. So that's where robots are going. I don't think they're I don't think they're going to take all our jobs or anything like that. Hopefully just the jobs that we don't want. Thank you.